Wait, are we supposed to not be able to hear you?
Oh my God, you can't hear me? Wow. I have been talking the whole time. That is
In the
crazy.
chat, but I wasn't sure if you saw.
Oh my God. Yeah, I didn't see it. Oof. Okay. I will just go ahead and start over. Can you guys follow what I was saying so far or no?
I was
I'll
able
just
to
start.
take notes like on everything you said, so like you can continue from where you were if you want.
Oh my God, that's crazy. Okay. Sorry about that. But yeah, so like you can kind of see because I was like kind of writing everything out. But thanks for bringing that to my attention. I guess I like had been muted and I didn't know. All right. Okay. So what I was kind of doing here was I was talking about finding a line. So in this question, he asks you to find a line and he gives you two coordinates. So the first thing is to do is to find m, so that's rise over run, y2 minus y1, blah, 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 that stuff. I found out m, and m is 1/2. So then I'm just going to go back to my first equation, and I'm just going to plug in any value of y, any value of x. Oh, well, they do have to be from the same coordinate, though. So you could choose either this one or this one. I went ahead and used 2 and 3 as my coordinates. And so I just plugged in 3 for y, and then 2 for x, and 1/2 for m. Then we can find b. So b is going to be equal to 3, and then like a 1/2 of 2 is just 1, so 3 minus 1. And then that is just going to be 2. So at this point we found m and we found b, so we can just write our equation. So our equation is going to be y equals 1/2 x plus 2. And that's your answer. Okay. Now, there's this other thing that he might ask you about where he's like, find the distance between 2 points. So if he asks you to find, let's just use the same coordinates in this case. So if he asks you to find the distance between 2 points, there's other ways of doing it, but you can also just memorize this formula. So, so distance equals the square root of, basically, it's y2 minus y1 squared plus x2 minus x2 minus x1 squared. So we can just plug that in. So y2 is 0, y1 is 3, oops, minus 0 minus 3 squared plus -4 minus 2 squared. And so we work through that. This is just 0 minus 3 is -3 squared, but -3 squared is going to be +3 because you're multiplying two -3's by each other. So it's -3 times -3, and negative times a negative is a positive. So this is +3, or sorry, +9. And then we have -6 from -4 minus 2. So that's -6. -6 squared is just going to be +36. And then from here, we just add those together, so that gets the square root of 45. And then from here, if you actually try, you can't really get the square root of 45. So we have to do this technique, which you absolutely have to do. You can't just leave it like this, because in this class in particular, it isn't like that. So basically, we're gonna find a number that you kind of like, that does have a square root in it. So let's just take this, and you have to find out two factors of it, and one of them has to be a square root. So I'm thinking 9 and 5, right? Because we have 9 and 5, so 9 actually has a square root. So you're going to kind of figure out two factors of like 45. One of them has to have a square root, like a complete square root. So 9 is that number. So we know that the square root of 9 is just 3. And then we can leave the square root of 5 in there. 5 doesn't have any more factors that are like square roots, that are squares, perfect squares. But basically, like, in this case, all you're doing is trying to, because we know this rule where it's like square root of x times y is just square root of x times the square root of y. You can kind of separate that. You cannot do that with addition. So if I had x plus y, you can't take that into the square root of x plus the square root of y. This does not work, but this is, the above one is fine. So that's why we do this whole process where we figure out two factors of 45 and one of them is square rootable. And that way you don't need a calculator to do any of this. Okay, let's talk about domains and ranges. So domains are kind of like I think domain is all the x values. Am I right? Domain is all the x values and range is all of the y values, from my understanding. Yes. So when we're doing this, the best thing is to kind of just look at your equation, like at your equation for hints as to which one is, so to what the range and domain are. So here is a function. So y equals x squared minus 5. So in this case, when we look at x values, right, anything can be squared, right? Anything. Like it's not really gonna change like what you're, basically there's no limits there, right? Anything can be squared. So we would say that our range, or sorry, our domain, because this is for domain, the x value. So we'd say that our domain is equal to negative infinity to positive infinity, because just any x value will work. Now, y is a little different. Now, basically, you'll notice that x is squared. So essentially, because x is squared, even if you put in like a negative 100, we would still get a positive outcome, right? Are we seeing this? Basically, this number is always negative 5, right? But the thing is that this y value is never really going to go that negative, because even if you plug a negative value into here, it's going to end up being positive in the overall equation. So y is going to be positive. So we know that, it can obviously go to positive infinity, but y is not really going to be negative infinity. I think y is going to stop at negative 5, right? Why is that? Because if I plug in 0 there, the answer will be negative 5. But I can't get this answer to be any more negative. As soon as I plug in like negative 2 minus 5 but squared, that's just going to be 4 minus 5, right? And 4 minus 5 is just negative 1. So negative 5 is the most negative it can get because of that square. So it's things like this that you really need to look for when you're glancing at your equation. And this is how you're going to figure out range versus domain. All right? So you need to look for little pitfalls like that. Now, another thing is if you have a square root, we know that we don't square root negative numbers, right? We can't take the square root of negative numbers. So that's like another thing, right? So you just want to look for things like that. Denominators. Denominators can never be 0, right? We can never have something divided by 0. If you try to put that into your calculator, it'll give you an error, right? You try it. 10 divided by 0. It's not going to work. So there's certain things you need to look out for that. I would say those are the major things. If you're looking at a square root, you have to know that every negative in a square root is going to be positive. And if you're looking at, that's a square, sorry. If you're looking at a square root, no negatives. If you're looking at a, what was the last one I said? If something is in the denominator, no zeros. All right, that's impossible. I think that's the main things that I look for. I don't know if I'm forgetting something. All right, let's talk about the difference quotient just for practice. So here's an equation, and I'm just going to use the same one that we talked about up above. This one, y equals x squared minus 5. So we're going to take y equals x squared minus 5, and we're going to have to use the difference quotient, and this will probably be on the final, so be prepared for it. Now the difference quotient is f of x plus 3, no, sorry, f of x plus h minus f of x over h, all right? So we're going to have to go and plug all this stuff in. So f of x plus h. So all we have to do is put this in, but also the h for every value of x. So I'm just going to go ahead and I'm going to write x plus h squared, right? No, yeah, plus, no, minus 5. I think this is the right way to do it. Yeah. Minus f of x, and then f of x is just x squared minus 5. So you basically plug, in this first situation, you plug x plus h for every value of x. So I did that here. This is where our x, had been x squared before, but I just put x plus h instead. And then in the second one, you just keep it normal. For the x's, you just plug in x. All right. So, and this is all divided by h. So now we need to go through and kind of solve this. So I think the best thing to do would be to start getting rid of these brackets and stuff. So we have an x plus h times an x plus h minus 5 minus x squared plus 5. Very important to keep those units over h. And then we're going to have to, multiply these out and stuff. So basically we're going to get an x squared plus 2hx plus h squared minus 5 minus x squared minus 5. And you'll notice that we have two x squareds, one over here, one over here. One's positive, one's negative, so it's perfect. And what else? Oops, this is over h. So basically, then we can kind of, I feel like something's not looking right, because it usually cancels out a lot more. Okay. Well, anyways, I guess we can just, continue. So, oh, this is supposed to be a positive 5. Okay, that makes a lot more sense. Yeah, so then our negative 5 and positive 5 can cancel out. And we're left with 2hx plus h squared over h. Now, is there a way to get rid of that h? Yes. Why don't we factor out an h in the top? So that would be 2x plus h, because I took out an h from each of those values, and then over h. So now these can cancel out, and we're left with 2x plus h. I hope I did that right. I'm not sure. Does it look good? Okay.
Yeah, on the
just,
test that we had, that was the one of the problems, and that was the right answer.
Oh, okay, perfect. Yeah. And I would definitely recommend absolutely knowing this before the final. Oh my God. Like it's one of those points that like it takes up a lot of points doing this question. So you really don't want to lose it because you didn't practice. And if you just practice, you can get there. But this is actually a good segue into f of g type questions because those kind of follow a similar kind of reasoning. So let's go ahead and do this one. So we have a problem where it says, so he's going to give you an f of x and a g of x. So f of x is x squared minus 1, and g of x is 1 over x. And Then he'll say, first find f of g, then find g of f, or something like that. So first let's find f of g of x. So basically what you have to do is you have to take the f function, and for every x value, you have to plug in the g function. So what I mean by this is, here's our f function. F of x equals x squared minus 1. Now, our f of g of f of x function is going to be that value of x that we had before. Just plug in the g, right? Take this and plug it in for the x value. So again, our x was squared, so we need to make sure to square it. And it minus 1, so we need to do that. So the only difference is you change that x, and you basically put in another equation for x. So this is f of g of x. And you might want to solve this, whatever. So this is just equal to 1 over x times 1 over x minus 1. Actually, no, never mind. There's no way to simplify this. So this is good. Good to go. Let's do g of f now. Oh, also quick question. What is the domain of this what do you call it? Of this equation? Domain means x values.
Negative infinity to positive infinity.
Well, remember what I said about 0? We can't put 0. So I'm not 100% sure on this, but I think the domain might be negative infinity. And then how do we skip 0? We have to probably say negative infinity to 0, but not including 0. And then also not including 0 to positive infinity. That's probably the correct way to say it, right?
Would there be brackets around the infinities then, instead of parentheses? Or no?
No. Infinities always have to have the rounded bracket, because you can't really include a number like infinity because it's not really a number. So I think this would be the best way of saying that, because we definitely can't put a 0 into the, into the denominator. And I think that's the only restriction, really. Okay, let's do g of f. Okay, so in g of f, you just take the g equation, which is 1 over x, but for the x, you're just going to plug in the f equation, so x squared minus 1, and that's it. Now here we can kind of, yeah, so basically, I think that like knowing this stuff is kind of related to knowing the difference quotient questions. It's all about plugging different things into different equations, but very important. Let's do a number line thing real quick before I move on to the exam 2 materials. So for number lines, basically, he might give you an equation, and he'll ask you to like show where something is below the x-axis, or it'll be like either where is it above the x-axis, or where is it below the x-axis, or he'll say, where is it equal to or above the x-axis. So you need to look for that kind of wording. But let's take this equation. F of x equals x squared minus x minus 6. And we're going to try to figure out where is it equal to or below. So less than or equal to the x-axis. All right. So this is really important wording to look out for, though. You want to look out for whether he says above or below or equal to. If there's an equal to, you need to make sure that your answer has brackets. So the first thing to do is kind of just go through and factor it. So x x. We want something that multiplies to be 6, adds up to be -1. So I'm thinking 3 and 2, -3, +2. And then from here, let's just draw out our number lines. So we need 2 number lines, one for each of these factors. Now let's put, so in our first factor, if x is, if x minus 3 equals 0, then x equals 3, right? So we're going to take 3, and we know that if we plugged in a number bigger than 3 for x, like if we plugged in 5, it would be positive. And if we plugged in something lower, not less than 3, our answer would be negative. So that's basically how it's going to look. Second one, let's do x plus 2 for that one. So x plus 2 equals 0. So that means x equals -2. If we plug in something bigger than -2, right, here's -2, it would be positive. And if we plugged in something less than 2, it would be negative. And then we're just going to put these two together. So just bring down your -2, bring down your 3. And then from here, you're just going to add them up. So a positive and positive are going to give you positives. Negatives and positives are going to give you negatives. Negatives and negatives are going to give you positives. So you're just adding them up in these columns. And then the question was equal to or less than or below the x-axis. So below the x-axis means in this portion here where it's negative. So it's going to be from, and he said below, at or below. So we're going to include -2 and 3. So it's between -2 and 3, including 2 and 3, because 2 and 3 are the zeros of our equation. So they are the part that's exactly on the x-axis. So that's why we need to include them. All right. So I think that's good. Any questions about exam 1? If you look at your old exams, do you have any questions based on anything there? My advice is don't stress out about the exam, but definitely look over your exams very carefully. Look at all the problems, make sure you can do them on your own, and then you'll be fine. Okay, so there's a video on YouTube about exam 2, so if I want to review exam 2, I might go to that. Now, I'm just going to pick out one question from there, the one that I didn't get to do actually, about finding the vertex and stuff of a quadratic. So we'll probably do that, and then we might touch upon the higher degree polynomials one more time. And then that'll be it for today. So in this problem, and this is the one from the YouTube video, he says f of x equals x squared minus 6x. So he says find the vertex. So what do we know of the vertex? The vertex is basically the point where it's kind of like either like if it went like this, it would be this point right here, or if it was upside down, it would be this point right here. So it's basically like the very bottom or the very top, either way. So basically the way that you can find the vertex, the best way is to kind of, you can just use an equation. So the equation is x equals -b over 2a. So the other way is to kind of find the two zeros. So if we have if we have some kind of axes there, you can find the two zeros. Then you can find the exact spot that's halfway between them, and then plug in the x value to find out what the y is. But this is just another way as well. They're both cool. So b is, in this case, is just going to be 1, right? Or no, 0. Wait, no. Okay, yeah. It's going to be -6, right? Because this is mx squared or plus bx, yeah. So b is -2, and that is over 2 times a, and a, oh no, sorry. This is a, okay. So, and a is just 1. So then, so calculate all that, whatever. So, -6 over 2, that is going to be 3, and then, but there's another negative sign, so it's going to be +3, right? So that's our vertex. And then he says find the y-intercept, or sorry, find the x-intercept. So for finding the x-intercept, basically what we're going to have to do is we're going to have to kind of like plug in, wait just a second. Oops. Okay. So this is the x value of the vertex. But when he says vertex, we actually want coordinates. So we need to find out the y value for that. So yeah, that was not enough. So once we found out the x value of the vertex, we need to find out the y value. So for that, we're just going to plug in the regular equation. So y equals, and I'm just going to plug in 3 for the x's. Okay. So then that's just going to be 3 squared is going to be 9, and this is 18, and that gives us -9, right? 9 minus 18. So then we can kind of write it. So the coordinates are going to be, yeah, that's actually really important because that's something that I would forget in his class sometimes, that you have to give coordinates as your answer. All right, let's find the x-intercept. So for the x-intercept, basically what you're going to do is you're going to, now what are x-intercepts? X-intercepts are like when you have your graph, the spots that might be the exact touching the x-intercept. So those are also known as the roots, whatever. So for that, you just kind of find the zeros of the equation. So y equals x squared minus 6x. Let's find the squares of this, or the roots of this. The roots are going to be, oh, it's easier than that. Just take out an x. Those are our roots. So one of our roots is x equals 0, and the other one is x equals 6 from these two factors, these two individual factors. And then once you have these x-intercepts, we just need to put them, you know, in the proper form. So our x-intercepts are x is 0 and y is 0, x is 6, y is 0. Because the definition of being at an x-intercept is that y equals 0. Because the fact that you're here means that your y value is 0. It's not above 0, it's not below 0, it's exactly 0. So that's why there's a 0 in both of the y's. Okay. Now for the y-intercept. So finding the y-intercept is a little bit more involved because we haven't done this, you know, like multiple times the way that we've done x-intercepts. But, oh, actually, no. Wait just a second. So if we want to find the y-intercept, in this case, it's actually pretty easy though. So if we want to find the y-intercept, just plug in 0 for all the x's, because if you think about it, if it's gonna be a y-intercept, meaning that it's right at the y-axis, the x value is going to be not more, not less, it's going to be exactly 0, right? So you just plug in zeros for all of your x's. So this is going to be 0 squared minus 6 times 0. So that's just 0, whatever. So the y-intercept is 0, 0. Now, y, we found out that that's going to be 0, but for x, it's obvious from the fact that it's a y-intercept that it's going to be 0. Okay. Now, let's just go ahead and try to factor this higher degree polynomial. This stuff is always really, really confusing. So I guess we can just use as many times as we go over as possible. So I'm using the same one from the video. So x cubed minus 8x. And for the rest of the stuff, I would definitely just watch the video again. I have the stuff about logs on there and all that. All right, so here is our polynomial. So to start off with, we're going to have to notice the p's and z's, okay? And basically, the z values here are going to be, the z value is this one. And the z value here is z equals 1. The p value can equal anything else. But basically what you're doing is you're kind of figuring out wait a second. Now I'm confused about why we even do P and Z. Does anyone remember? This topic is like every time I revisit it with you guys, it's like I can't remember what to do. I'm confused about why we're even doing P and Z. But I mean, basically, we gotta look for, we're gonna start trying by plugging in numbers to find something that when you add it all up, it equals 0. Okay, that's the important part. So I'm just gonna skip this, I guess. You can watch the video, see why P and Z's are useful. But usually what I do is I start out with trying 1, because you can just go for like a number that might equal everything to 0. You need to set it to 0. So basically, you can go ahead and you can try 1. So when we try 1, we get 1 cubed minus 8 times 1 squared plus 11 times 1 plus 20. Well, that's kind of, you know, right off the bat, clearly not going to work because this is just going to be a really positive number. So we have 1 minus 8 plus 11 plus 20, and that all equals out to be 20 minus 11, 24. Yeah. So then from this point, we know that that's obviously not going to work. So let's try -1. So for -1, so I usually just start with 1, then go -1, and then maybe 2 or -2. But usually you'll get it in the first few tries. So -1 cubed minus 8 times -1 squared plus 11 times -1 plus 20. This is looking a lot more hopeful. So -1 cubed is just going to give us -1. And then -1 squared is going to give us a positive, but it's already a negative, so that's -8. And then this is going to be -11, and this is going to be positive 20. So then this is going to equal, so 11 minus 8 is -19, minus 1, that's -20. So it's basically 20 minus 20, which is 0. So we've got it. We're going to be using -1. Now, if you say, basically, if you put x minus 1 as your factor, right, this is our factor, then x equals 1, right? If you use x minus 1 as your factor, then x is going to be equal to 1. So let's go ahead and start using this. Now, basically set up your whole thing, right? It's going to be long. And you're going to put your entire equation underneath. So that is x cubed minus 8x squared plus 11x plus 20x, or just plus 20. And on the outside, we're going to have x plus 1. Now, from here, we're going to start with trying to kind of work through it. So the first thing we're going to do is we're going to start out by finding something that makes x squared. So if you take an x squared times an x, you're going to get x cubed. So that's perfect. So we're going to take an x squared, and we're multiplying this x squared by the x and also by the 1. So what we get is x cubed, right? Plus x squared, right? And then basically what we have to do here is we're subtracting all this. So I'll put it on the outside. We're subtracting all this. And basically this gets canceled with this. So that's good. That's what we're aiming for here. And then, you know, this is kind of gonna also be subtracted as well. So negative 8x minus negative 8x squared minus x squared is just negative 9x squared, right? And then from here, we're just going to continue with the whole process. So we want to make this x cancel out with the x squared down here. So we have to multiply it by a 9x, okay? So when you go 9x times x, that gives you 9x squared, right? But notice something here. Again, we're subtracting, right? When you subtract, you know, this is already negative, right? So since it's already negative and you're subtracting it, it's just going to become very negative, like negative 18. So now we know that this must be subtracted up here. This 9x has to be subtracted up here because that will make this negative in here. When you distribute your negatives, you're going to get a positive, and that'll be perfect to cancel them out. Okay, so I'll go through that one more time in just a second. But basically, we also have to make sure that our 9x gets multiplied on there. So that's just going to be, that's going to be minus 9x, right? So our answer is negative 9x squared minus 9x. Now, we're subtracting this, right? So this becomes a positive, this becomes a positive. Now that this is a positive, perfect. We can cancel it out with the above one. And then from here, we're going to try to get rid of the, oh wait, oops. I think I forgot to bring something down. Yes, you need to bring your positive 11x down from here as you're going. That needs to be done. So positive 11x plus 9x, that is 20x, positive 20x, right? Yeah, positive 20x. And then we're just going to try to cancel the 20x out. So over here, we notice that we're probably just going to multiply this by 20 to cancel it with 20x. So 20 times x is 20x. 20 times 1 is just 20. This is all being subtracted, so these can cancel out, and we're left with that. So now we're left with a negative 20 here. But we also need to bring this one down, right? So that's positive 20 cancels out with a negative 20, so we've got no remainder. And that's perfect. So now we have two factors. We have this one and we have this one. I'll circle them in blue. This right here, what was on top, and also what was on the side. Now, once we're here, we're actually not done yet because we know x plus 1 is a factor. But this is not factored. The other one is not factored enough yet. It's x squared minus 9x plus 20. So we need to factor it, you know, beyond that. But that part is easy because at this point, it's just a quadratic. So we're just going to write out our normal things. And essentially, we want something that's going to multiply to be 20 and add up to be negative 9. So maybe like 4 and 5. 4 and 5. And maybe we want both of them negative, yeah. Negative 4, oops, negative 5. And then so here we know all of our factors now. Here's 1, here's 1, here's 1. And we're done. I think the question was, what are the factors? And these are all the factors. If he had asked what are all these zeros or all the x values, then you might just want to convert them to x values. So converting them to x values would be x equals -1, x equals 5, and x equals 4. But this isn't really, the question was asking for factors, and these are all the factors. Okay, so we have 4 minutes left. Are there any questions? So one thing I would say is like definitely look at those bonus questions on your 2 exams. Because you never know if he's like gonna give you the same like in something similar on the final as your bonus question, but it also could be new. And then also just study that new stuff really well, the stuff about trig, because we didn't get to go over it. So, you'll kind of be prepared for the exam the best way that way. Um, and then the other thing to look out for is the exponents and logarithm stuff, which is kind of tricky. So definitely do the video and then do all your quizzes and exams on that because it can be hard to figure out what you have to do without a calculator. But yeah, so are there any questions or anything or no? Okay, I will let you guys go for today. Can you guys just all send your Maisie, I need your net ID. If you could just send that in the chat. That would be great. Thanks. All right, well, good luck everyone. And yeah, good luck on your exam. And what do you call it? Study hard.
Yeah.
Thank you for coming.